Hi everyone. Notes 5.2 are on multiplying polynomials part 2. So this is the second day of these notes. For multiplying these polynomials, what we'll end up doing is we'll actually end up doing it several different ways, and then you can choose which method you prefer, okay, when you're actually doing some practice problems. So if you remember, just a reminder, if we have something like 5x times x minus 4, in order for me to be able to multiply this together, I have to multiply 5x to the x and 5x to the negative 4. So I end up getting 5x squared, because 5x times x, I always add my exponents, and then 5x times negative 4 is negative 20x, and this is my answer right here. So like I said, I'm going to show you two different methods that you can use in order to solve this, and then you can choose whichever one you prefer. Okay, so method 1, I'm just going to copy the problem down. So it's x plus 4 times x minus 3. This time I have two things that need to get distributed as opposed to one thing. So what we're going to do is we're going to use a method called FOIL. So FOIL, so let's go ahead and write down this is FOIL. FOIL is just going to show us how we can make sure that we distribute to every term, pretty much. So everything in the first set of brackets gets distributed to everything in the second set of brackets. So in order for us to be able to make sure that we actually do that, we're going to write down what FOIL stands for. So FOIL stands for, the F stands for first, the O stands for outside, or outer. The I stands for inside, and the L stands for last. And if you notice, this right here gives us FOIL. So when I say first, what you need to do is you need to take the first term, and I'm going to color code it so you can see each one of these. You're going to take the first term in your first set of brackets, and you're going to multiply it by the first term in your second set of brackets. So I'm going to multiply x times x, and when I do that, I end up getting x to the power of 2, because this is x to the power of 1 and this is x to the power of 1. Okay, so when I do that, I get x to the power of 2. Now the next letter in FOIL is outside. So I'm going to multiply this x on the outside right here. So on the left side, the x is all the way on the outside. On the right side, we've got negative 3 on the outside. So we multiply x by negative 3, and that gives us negative 3x. Okay? The I stands for inside, so I'm going to multiply my inside terms, and 4 times x is positive 4x. So I'm going to write down plus 4x. And then the L stands for last. So I'm going to do the last in each set of brackets. So if the 4 is the last term in this set of brackets, the negative 3 is the last term in this set of brackets, and 4 times negative 3 is negative 12. Okay? So now I'm going to collect like terms. So x squared, there's nothing else like it, so I'm going to write down x squared. Okay? Then I've got, over here, I've got negative 3x and positive 4x. And negative 3x and positive 4x are like each other because they both have x's on them. So I'm going to figure out what this is when I put them together. So negative 3 plus 4 gives me positive 1. So this means that I end up getting positive 1x, but I'm just going to write plus x, because since it's positive, we put a plus sign, and since it's 1x, it just means you have an x there. Okay? And then lastly, we have negative 12, and nothing else is like it, so I just copy it down, and this is my final answer. Okay? That's the first method. The second method that I want you guys to get down, and I want you to get both methods down, is to look at it as follows. When we're multiplying, we're pretty much just finding area. So we're using a geometric model. So if you notice, this is 2 terms and this is 2 terms. So this ends up being a 2 by 2 problem. So if you notice here, my first term is x, so I'm going to put x on top. Then I have a positive 4, so I'm going to put a 4 next to it because that's one set of brackets. And then on the side here, we have x, and we have negative 3. So to figure out what goes in each one of these boxes, I'm going to multiply. In this box right here, it will be x times x. Now this is x to the power of 1 and x to the power of 1. So when I multiply those together, I get x to the power of 2, because remember, when you multiply, you add exponents. Okay? Then I'm going to, in this box right here, it would be x times 4. So x times 4 is just 4x. Okay? In this box over here, it's negative 3 times x. So negative 3 times x is negative 3x. Okay? And then in this box in the corner over here, I end up getting negative 3 times positive 4, which is negative 12. And then the last thing I need to do is collect like terms once I create my box and I fill in every number inside of here. So nothing is like x squared, so I'm going to copy x squared down. Okay? Then 4x and negative 3x are like each other. So I'm going to put those two together just like I did right here. And 4 minus 3 is 1, so I get positive 1x. Okay? And then nothing's like this negative 12, so I'm going to just copy it down, and that's my answer right here. And I end up getting the same answer either way. The only thing I just want you guys to be aware of is FOIL only works if it's a 2 by 2. If it's anything other than 2 terms or a binomial times a binomial, then it will not work. Okay? Now, I prefer method 3, so I'm going to go over the rest of this worksheet or this notes package or this set of notes using the third method. So if you notice right here, we've got 2 terms by 2 terms. So what I'm going to do is I'm going to draw a box that is 2 by 2. And here I've got 5h, and here I have to write negative 2 because this says minus 2. And on this side right here, I'm going to write 3h, and I'm going to write 8. Okay? So to figure out what goes in this box, it's 3h times 5h, which is 15h to the power of 2, because you always add your exponents. Okay? And then right here, to figure out what goes in this box, it's 3h by negative 2, so you get negative 6h. To figure out what goes in this box, it's 8 times 5h, so 8 times 5 is 40, so I get 40h. Okay? And then to figure out what goes in this box right here, it's 8 times negative 2, which is negative 16. Okay? Now, nothing's like this 15h squared right here, so I'm going to just copy it down. Now I have this negative 6h and this positive 40h, and those are like each other. So if I were to put negative 6 and positive 40 together, I end up getting 34, positive 34. So I'm going to write plus 34h. Okay, and then this minus 16, nothing's like it, so it tags along, and that's my answer. Okay, all right, let's take a look at number 2. I've got 2 terms here and 2 terms here, so again, it's going to be 2 by 2. So here, I'm going to put c minus 6, so I've got c and negative 6. Here, I'm going to put c and negative 2. Okay, so to figure out what goes in this box, I'm going to do c times c. It's c to the power of 1 times c to the power of 1, so I get c to the power of 2. In this box right here, it's c times negative 6, so I get negative 6c. In this box here, it's negative 2 times c, so I get negative 2c. And then when I do negative 2 times negative 6, I get positive 12. So now to put together my like terms, c squared, nothing's like it, so I'm going to write down c squared. Negative 6c and negative 2c are like each other. So I'm going to put those together. And if I were to do negative 6 minus 2, I get negative 8, so this would be negative 8c. And then this 12 right here just tags along, so it's plus 12. Okay? The next one we have here is also a 2 by 2. So we're going to also put a 2 by 2 right here in our work right here. So here I'm going to put w, here I'm going to put negative 3 because it's a minus 3. Here I'm going to put w, and here I'm going to put positive 3. So let's go ahead and multiply. W to the power of 1 times w to the power of 1 gives me w to the power of 2. Here, w times negative 3 is negative 3w. Over here, we've got 3 times w, which would give me positive 3w. And then lastly, right here, we have 3 times negative 3, which is negative 9. So w squared, nothing's like it, so I'm going to copy that down. Negative 3w is like 3w, but they're opposites of each other. So they're going to completely cancel each other out. So there's no w's left over. And then we just copy down the minus 9, and that's our answer for this one right here. Okay, so now question number 4 is where things get a little bit different. This time it's a 3 by 2. Okay, so what I'm going to do is I'm going to draw out a 3 by 2 instead of a 2 by 2. So right here, I'm going to have 3 in this direction and 2 in this direction. If you want to do it the opposite way, it doesn't matter. It's up to you. Okay? Since I put the 3 on top, I'm going to put each of my 3 terms on top here. So my first term is x squared, the next one is 2x, and the last one is 1. And then over here on the left side, I'm going to put 3x right here and positive 5. So let's go ahead and figure this out. So 3x to the power of 1 times 1x to the power of 2. 3 times 1 is 3. And then when I add my exponents, I get x to the power of 3. For the next term, I'm going to do 3x times 2x. And this is 3x to the power of 1 times 2x to the power of 1. Well, 3 times 2 is 6. And then when I multiply, I add my exponents, so I get x to the power of 2. For my next one here, I've got 3x times positive 1. So 3x times 1 is just going to be 3x because anything times 1 is itself. Okay? For the next one, I've got 5 times 1x squared. So 5 times 1 is 5, and then the x squared just tags along. Okay? Next, we have 5 times 2x. So 5 times 2 is 10, and then the x tags along here. And then for my last term right here, it's just going to be 5 times 1, which is 5. So now I'm just going to put together all the things that are like each other. So 3x cubed, nothing is like it, so I'm just going to copy it down. Okay? 6x squared and 5x squared are like each other, so I'm going to put these two guys together. So 6 plus 5 is 11, so I get plus 11x squared. Okay? Over here, 3x and 10x are like each other, so 3x plus 10x is 13x. And then this 5 just tags along because nothing else is like it, and that's my answer right here. Okay? Now, in number 5, we need to be careful about what this is saying. So in number 5, because it's squared, it means I'm going to square everything in the bracket. So I'm going to rewrite everything in the bracket. So essentially, it just means 7x minus 3 times 7x minus 3. So right here, when I do this one right here, what I'm going to do is a 2 by 2 right here, and I'm going to put 7x on top, negative 3 here, and then I'm going to put 7x here and negative 3 here. Okay, so 7x to the power of 1 times 7x to the power of 1, 7 times 7 is 49, and then add your exponents, you get x to the power of 2. For the next term, I'm going to multiply this 7x by this negative 3. So 7 times negative 3 is negative 21, and then the x just tags along. Okay? Now, I'm going to multiply negative 3 by 7x, and negative 3 times 7 is negative 21 again, and the x tags along. And then lastly here, -3 times -3 gives me +9. So now let's go ahead and put together all of our terms. So 49x squared, nothing is like it, so I'm going to copy it down. Okay? -21x and -21x, this time they don't cancel each other out because they're both the same sign. So I'm going to figure out -21 minus 21 gives me -42. So this right here should be -42x. And then right here, I've got this +9, just tags along, and that's my final answer. Now, one thing I want you to notice is this to the power of 2 means squared, and if you notice right here, we end up getting a square right here. So for number 6, it's a 3 by 3, but it's also squared, so it means that we're going to do a square that is 3 by 3. So this ends up looking more like this. Now, right here, I'm going to put 2x squared, 5x, and -1. Here I'm going to put 2x squared, 5x, and -1. This is a challenge problem. If you would like to complete it, please feel free to do so. It will be good to expand your understanding of this material, and if you can do number 6, then you can pretty much do anything that I give you. Okay? All right, that's it for today. Let me know if you have any questions, and good luck with your problem set. Okay, bye.